AI.
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 AI. AI.
AI.
AI.
AI. These two letters are literally everywhere. In your browser, in your $80 game, in your IDE. Some people are even trusting AI with their deepest psychological traumas. And my washing machine now has 3 AI features in its name, so it can fine-tune its drum. But we're not going to talk about AI washing machines today. Let's focus on large language models. These fellas can make literally anything smart with just some API requests. But how did we even get here? Recently, AI was just struggling with basic translations. And now it's doing your taxes? What actually changed since then? Stay with me here. Today, we're diving into the key breakthroughs that transformed AI from kinda predicts the next word to here's why your code stinks. Let's go back to June 2020. Language models were already a thing. We had generative pre-trained transformers GPT-1 and GPT-2. Basically, they're just neural networks that predict the next word in a sentence. They could write some text, maybe a poem, but that was pretty lame and useless. Then OpenAI drops GPT-3, and this thing was massive. It had 175 billion parameters. That's over 100 times bigger than GPT-2. It could write essays that looked human. It could generate code in Python and JavaScript, create HTML web pages, and even compose guitar tabs. GPT-3 was the game changer. But pause. How was this even possible? Why was GPT-3 suddenly so much better? Turns out it all came down to the scaling hypothesis. The idea was simple. Make GPT-2 again, but 100 times bigger. At this massive scale, the model just started doing things nobody programmed it to do. It developed zero-shot learning. You could ask it to do tasks it had never trained on, and it would just figure it out. And it got few-shot learning too. Give it a couple examples of a new task, and somehow it understands the pattern perfectly. This was insane because before GPT-3, you had to fine-tune models with thousands of examples for every single task. Now, just show it a few examples and boom, it just gets it. Fast forward to March 2023. OpenAI drops GPT 3.5 and opens up the API. Everyone and their mom started building AI startups. VC money started flowing like crazy. AI research papers dropping every single day. GPT-3 basically set the bar. This is what you had to beat now. But wait, how do you even compete with that? Alright, so GPT-3 was amazing, but it had this one massive problem. It sucked at complex reasoning. You'd ask it to solve a multi-step math problem and it would just YOLO the answer. No work shown, no steps, only vibes. It jumped straight to conclusions instead of thinking step by step like actual humans do. Then researchers discovered something absolutely brilliant. Just ask the model to show its work. Instead of what's the answer, you say, explain your thoughts step by step. That's it. And the results were impressive. Models suddenly got way better at math, logic, and problem solving. This became the foundation for literally every modern LLM after. OpenAI even baked chain of thought reasoning directly into the training of GPT-4. It's became the built-in feature now. So now LLMs can handle reasoning tasks that seemed completely impossible a few years ago. They break down complex requests, make plans, debug legacy code, keep in mind multiple constraints, catch their own mistakes, and retry. All of that computational power, so they can finally count the R's in strawberry correctly. But chain of thought was just the start of the reasoning revolution, because in January 2025, a challenger appeared from the other side of the globe. DeepSeek. Relatively small Chinese AI company drops their R1 model, and the entire market loses its mind. Big tech companies lost billions in market cap overnight. Jensen Huang personally lost $20 billion in a single damn day. Why? Because DeepSeek just proved you could build a reasoning model that competes with OpenAI's top tier, but much cheaper. While everyone else was out here potentially spending over $100 million. DeepSeek did it in 6 mils. How is that? See, traditionally, making LLMs reason well was this complex thing. You needed thousands of human-written examples showing perfect reasoning, super expensive and super time-consuming. DeepSeek just said, what if we skip all that? They made R1.0 using only the thing called reinforcement learning. They didn't have humans judging if the reasoning was good. They just checked. The end answer is right or wrong. And the model taught itself to reason, catch its own mistakes, and verify its work just by chasing only correct answers. It developed all these complex reasoning skills completely on its own. Nobody showed it how. The impact? Yeah, that was a lot of damage. They proved you don't need infinite money or armies of human labelers. And they made it open source. Top-tier reasoning capabilities for everyone, just out there, for free. And with better reasoning models, we could finally build agents that are not completely stupid. Speaking of which, with these smarter reasoning models, we suddenly got this explosion of coding agents. Like, literally, every day there's a new agent dropping. It's getting ridiculous. But wait, what even is an agent? Agent is basically an LLM that can use tools and remember what the hell it's doing. It's got memory, it's got states, it tracks progress, remembers what it tried before, and can handle complex tasks that take more than 5 seconds. But what made this agent explosion possible? Why are they suddenly so good and getting easier to build? First, LLMs got really good at tool calling. A tool is just a description that tells the LLM, hey, you can trigger this function. When the LLM wants to use it, it spits out some required JSON, your agent reads it, and executes the required tool. Problem was, every AI company was doing their own weird custom protocol for that, and first couple of years, it was a total mess. Then we got Modern Context Protocol, MCP. Instead of chaos, MCP created one standard way for any LLM to talk to any tool. Think of MCP servers like universal adapters. One plugs into GitHub, another into your database, another into your file system. Now agents can read your GitHub issues, monitor your CI/CD pipelines, and the UX got way better too. We went from scary black terminals to these gorgeous interfaces where you can actually see what's changing in real time. Put it all together, smarter models, better tools, cleaner interfaces, and now you are worried about losing your job. The agent revolution is accelerating every single day. All right, look, these are just the big ones we covered today, but honestly, this is just the tip of the iceberg. I could make a 10-hour video series just covering 2024 alone. We're living through this exponential acceleration of AI research right now. Before, researchers couldn't find info about transformers because Google Ads thought they want to buy some electrical transformers, but now they can barely keep up with their own field anymore. Papers dropping faster than they can read them, and we're probably still at the very beginning of this whole thing. So, if you enjoyed this dive into why LLMs suddenly got so absurdly good, maybe, possibly, if you're not too busy, consider subscribing. I mean, no pressure, obviously. You've got stuff to do. I totally understand. But if you have a second,